we want to deal onto the computational electromagnetics. So if you want to see the electromagnetic field spread around your antenna or around your structure, whatever you're trying to develop, basically we have to go ahead with simulation softwares in order to analyze the performance of antennas or the structures, whatever you're trying to develop. So with the advancement of the simulation technologies, we are able to completely simulate and get the results of different structures, different phenomena with a very ease of time and ease of development things. But whereas in the earlier stages, whenever before invention of these simulation softwares, the scientists or so-called mathematicians used to do the analysis in terms of mathematical equations, and all the Green's functions, Maxwell's equations they used to compute, and they used to evaluate the performance of the particular antenna. But for that kind of things, it almost takes even though if you're a very good mathematician and if you're solving a complex problem, it takes around like at least like 15 to 20 days of time to completely solve the complete matrices and completely get the results out of it. But whereas due to the advancement of this computational electromagnetics, we are able to completely simulate the design. Sir. Through we get started with the design part, we'll be understanding how exactly this mesh works out, and we'll be dividing the subparts into a mesh, and this mesh will actually help us out in solving the complete problem. So you can see we have different, you can go with antenna integration study, you can go with antenna alone study, and if you're going with two antennas, how exactly one antenna is interfering with the other antennas. So interference study, EMI, EMC, different contributions are given by Simon software. So we'll be going with one by one, we'll be going with a different type of solvers and different type of methodologies what are adapted by ESI. So coming to SEM1 software solutions. So SEM1 solutions it's completely contributing the SEM tool based on both frequency domain and time domain. So based on the application, based on the complexity of the design, we'll be actually switching between different type of domains. So how exactly ESI SEM1 has come up? So if you see, we have two different companies actually, which is PAMSEM and eField Solutions. These are two different companies. Actually contributed the solutions onto different solutions. Later, both the companies have combined together to get started with the ESI SEM1. So you can see PAMSEM simulation suite. You have EMI, EMC, and other issues due to cabling were analyzed. Thunder lightning scattering and EM aggressions, active safety and radar devices, RCS, those kind of analysis were already given. And eField Solutions of frequency domain were giving radar signature and stealth, antenna design and integration. So SEM1 solution as a product from ESI, which is a Sweden group. So if you see how exactly those are collaborated, we'll go through first what are the solutions have been given by PAMSEM. So if you see, these are the solutions what we have got from PAMSEM, and these are the solutions what we have got from eField. So if you see finite difference in time domain, we have got it from PAMSEM, and then FDTD and PO for near radiated fields. PO is nothing but physical optics. And frequency domain crypt is nothing but so for transmission lines, if you want to do some study analysis, you can go for crypt. Similarly, frequency domain physical optics. For example, if you are solving a higher quality structure, or else you're going with a higher structure which is very long in terms of lambda, then we'll be going with physical optics. So from eField, we have got FDTD and time domain FEM as well. And apart from that, we are into frequency domain MLFM and MOM solvers and physical optics as well. So together we have combined all these softwares into a single suite, which is given by ESI SEM1, and the software name is VisualSEM. And we have also added an additional advantage in this. There is a methodology which is called as multi-domain multi-method, which actually saves a lot amount of time in terms of simulation. So graphical user interface, how exactly your graphical user interface is divided into. So we have a dedicated set of graphical user interfaces for different for different environments. This actually makes student or else a professor or else a researcher to easily switch between the things. So we have visual mesh, which is nothing but which is for your CAD data import, CAD cleaning, CAD meshing, tuning, the complete CAD optimization part. And the CAD, even the meshing part is completely related to visual mesh. That's the reason it is called as mesh. So whenever you are importing some design or you're just getting started with the small designs, you have to be getting started with visual mesh. And similarly, we have visual SEM. Visual SEM is nothing but computational electromagnetics window. Here we'll be assigning what kind of frequency you want to operate with, what is the external media, what kind of source you are dealing with, what is a boundary condition you have to assign, what is a material you want to assign, what kind of solver you want to go ahead with. If you want to go with cables, networks, how exactly you have to solve it, all these things. So the complete antenna parameters, what you want to visualize, you will be actually putting it in visual SEM window. Like frequency, it could be excitation, it could be your source, it could be your boundary conditions, it could be your materials, all those things. And coming to visual viewer is a window which actually helps in visualizing the results. So in this way, we have a perfect division between each and every environment. So we can switch from one environment to other environment very easily. So visual mesh, visual SEM, visual viewer. And in short note, visual mesh is for your CAD import, CAD optimization, meshing operations. And visual SEM is for assigning your parameters like frequency, excitations, boundary conditions, sources, solvers, etc. And visual viewer is to visualize your 2D output, 3D output, cut planes outputs, and similarly polar plots if you want to plot it, etc. And visual process executive, it is nothing but the flow, how exactly you have to go about. So this is a complete graphical user interface what we have. And applications of SEM solution suite, we are into like antenna designing, antenna integration, scattering, and radar cross section, where it will be actually helpful in analyzing the stealth and even like RCS of a structure and even the UAVs as well, EMI EMC interactions, and microwave design as well. So these are the applications of SEM solution suite. So before getting started up with the other part, so I'll just switch on to the introduction on visual SEM. So we have a basic intro. So I'll not cover much into this. So basic parts, whichever are required, I'll be covering up. So introduction to visual SEM. So as I've told you, we have three main parts: mesh, SEM, and viewer. So you can see CAD import, create, and repair. And similarly, meshing. Similarly, you can see for SEM, material boundary conditions, excitations and sources, solver settings and job manager, viewer, result visualization. So what are the geometry files you can actually make use of? You can use of IGS, STP files. When you're dealing with visual SEM in antenna designing, you can go with IGS and STP files. And these are all the different geometry files are supported by different softwares which are under ESI suite, under ESI multi-physics suite. So if you see, visual SEM is the software which is actually completely dealing with the antenna designing part. So this is the environment of visual SEM. Let us just open visual SEM and have a look at it. So this is what is the window, what we'll be getting it. Here at the left top, you will be actually getting an application window. Here you can see process executive, mesh, SEM, and viewer. So mesh is the initial window where you'll be doing your CAD creation, import, repair, etc. And also for mesh assignment also. Similarly for SEM, all the properties assignment, and viewer for results.